Good morning, everyone. So, any confusion regarding your last class? Any doubt? No confusion? No doubt? Okay. So, what do you mean by von Neumann architecture? Can anyone tell me? What is von Neumann architecture? What is von Neumann architecture?
Sir,
Yes. Yes. What is the difference between von Neumann architecture and Howard architecture? No idea? And you don't have any confusion और उसके साथ साथ आप लोगों को confusion भी नहीं है और ना
In von Neumann, the memory is stored in linear way, but in Howard, it is not.
what you are saying? Von Neumann architecture?
So may I speak?
So,
Yes, one by one. Aman, please start. You
So
first.
von Neumann architecture is half duplex and Howard architecture is full duplex.
No. Von Neumann architecture is
So-
not half duplex. It is not a distinction between these two. Yes.
So von Neumann, there is same memory which holds both program and data. And in
Yes.
Harvard architecture, there are different memories for program and data. There are two different memories which hold program and
Yes,
data.
yes. That is the main difference between the von Neumann and Harvard architecture is the program and data is stored in the same memory in von Neumann, but in case of Harvard architecture, they have different types of memory. Program memory is different and then data memory is different. That is the main difference between these two architecture. Please remember. Half duplex, full duplex, duplex, these are not the differentiation between these two. हाफ डुप्लेक्स कहाँ पे हो रहा है? बसेस में वहां पे भी हाफ डुप्लेक्स हो सकता है और होता है और यहाँ पे भी हो सकता है. That is not the differentiation between these two architecture. Main difference between these two architecture is program and data memory is same in von Neumann architecture, but in case of Howard architecture, program and data memory is different. They have separated in Howard architecture, but in case of von Neumann, both are same. Parallel execution is supported by the architecture in Howard architecture, but through architecture we cannot achieve parallel execution in case of von Neumann architecture. That is the one more differences between these two. So main difference is that one. Program and data memory is different in Howard and program and data memory is same in case of von Neumann. बाकी जो है वो स्लाइड में दिया हुआ है, मैंने आपको पढ़ने के लिए बोला था आप सबको, आप लोगों ने वो ध्यान से पढ़ा नहीं है. So that's not the ये ऐसे नहीं चलने वाला, इस तरह से नहीं हो पाएगा. आपको जो भी मैं पढ़ने बोलता हूँ वो आपको पढ़ना पड़ेगा और उसके बाद मैं यहाँ पे क्वेश्चन करूंगा. अगर नहीं कर पाए आप लोग तो आपका मार्क्स भी डिडक्ट हो सकता है फ्रॉम द नेक्स्ट क्लास. आज के लिए मैंने आपको बता दिया कि आपको जो भी प्रीवियस क्लासेस में पढ़ने दिया गया है या आपको बोला गया है या वो क्लास में बताया गया है, यू नीड टू रिवाइज बिफोर कमिंग टू द नेक्स्ट क्लास. ओके. Today we will discuss Boolean algebra. In Boolean algebra, we will see logic gates. This is the first chapter of your digital electronics actually. अभी तक जो हम लोग देख रहे थे ना, von Neumann, Harvard, functional units, those are basics, computer fundamentals. This von Neumann architecture, Harvard architecture, Your functional units. What are the functional units we have in our machine? Can anyone tell me? Central processing unit, then control unit, arithmetic logic unit, input output and memory. These are the functional units. आपके syllabus पे एक syllabus पे दिया गया है यहाँ पे. First, evaluation of computer, that is your homework. Then I have discussed von Neumann architecture, Moore's law. I have already discussed in the first class. Then you have computer types and functional unit devices. That is your input, output, storage and communication devices. This is known to you. These things known to you. You people know what is input devices, what is output devices. Your keyboard is input, monitor is output device, then printer, scanner, all these things it is known to you. These are all basics. ठीक है, आप प्लीज इसको एक एक बार पढ़ लेना. Then memory system we will discuss later because we need some more concepts about your architecture. यहाँ पे RAM, ROM, cache and virtual memory दिया गया है. We will discuss this topic later on. Today I will discuss introduction to logic gates. Introduction to logic gate is the first chapter of your digital electronics. If you study digital electronics, the first chapter is logic gates. So what is logic gates we will see today. Okay, so these are your logic gates. Actually, primarily we have three fundamental gate. First one is NOT, then AND and OR. NOT, AND and OR. These three can be derived using these three. So fundamental gates in any digital electronics are AND or NOT. AND or NOT means, what is NOT gate? NOT gate is an inverter. Whatever you signal you have passed through this gate, you will get the reverse of that signal. If you pass 0, then in the output you will get 1. If you pass 1, you will get 0 at the output. So this is the symbol of NOT gate. नॉट गेट कैसे लिखा जाता है? इस तरह से लिखा जाता है. यहाँ पे एक इस तरह बनाया जाता है, आगे में एक गोल करके रखा जाता है सर्कल. Then this is the output, this is the input. This is input, I means input, O means output. So input 0, output will be 1. Input 1, output will be 0. So whatever you are supplying at the input, you will get the reverse of that input. Not gate. Not gate means it is inverse. Okay, is this clear? Not gate. Not gate is clear. Okay, then AND. What is AND gate? AND gate is, in this case, this is the first AND gate and this is the second AND gate. They have shown here two input AND gate. Two input AND gate means we have two input, one output. Already I told you people in the first class when I discussed Moore's law, our PCs are getting heated. हीट होता है कि नहीं? हीट जनरेट होता है कि नहीं? इसीलिए हमको हीट सिंक चाहिए. हमारे प्रोसेसर के ऊपर देखना एक हीट सिंक लगा रहता है. हम लोग हीट सिंक यूज करते हैं. Why? Because of this factor that you can see, this is our two input AND gate and this is our three input AND gate. कितना भी इनपुट बढ़ा लो लेकिन आउटपुट में बस एक ही मिलने वाला है आपको. So this is the main factor of generating heat. आपने दो इनपुट दिया, एक आउटपुट में है. That means you are getting, and that means you are losing one input in the gate. You are losing one input in the form of heat. यहाँ पे आपका कितना है? एक ही आउटपुट है. One output, two input in the first gate. In the second gate, three input, one output. That means you are losing inputs within the gate and you are getting only one output. And those inputs are generating heat. ठीक है, ये बाद में आपको पता चलने वाला है. ये यहाँ पे डिस्कशन का चीज नहीं है, फिर भी मैंने बता दिया, रिमाइंड करा दिया क्यों हीट जनरेट होता है. बिकॉज ऑफ our architecture, because in the architecture, in the chipset, we are using fundamental gates, basic logic gates, and those gates are not, that means number of inputs are not equal to number of outputs. Input always higher than your output. आउटपुट में बस एक ही रहता है, लेकिन इनपुट में 1 2 3 4 कुछ भी हो सकता है. In this case they are showing two input and get, and two input, three input and get. If you are using two input and get, then x y, that means you are it can generate it xy, that means you are providing xy and they are multiplying it. And get means this is nothing but multiplication. Okay, and get is a symbol of multiplication, x into y. यहाँ पे आप देख सकते हो x y z, you are getting x y z in the output, that means x into y, y into z. Okay, and similarly in the or gate means it is addition. Or gate means addition, two input or gate and three input or gate. It is shown here, x plus y, and then if you are using three input, then you are getting x plus y plus z. And these three gates, NAND, NOR and XOR. NAND gate means and not, and not, you will get NAND gate. Or and not, you will get NOR gate. And XOR, it is different kind of gate, we will discuss later. So basically we have three input gates, sorry, three fundamental gates. First is NOT gate, AND gate and OR gate. बाकी तीन हम लोग बाद में डिस्कस करेंगे. First you concentrate three fundamental gates that are NOT, AND, OR, because these three can be derived from using these three. Any gate you can derive from the fundamental gates. Fundamental gate कौन सा है? Then AND gate, OR gate and NOT gate. If you have AND, OR and NOT in your disposal, then you can generate any gate combining all these three. Okay, NAND gate can be generated using AND NOT. NOR gate can be generated using OR and NOT, and XOR also can be generated using these three. Okay, we will see later, but primarily we have three fundamental gates that are NOT and OR. NOT means it is generating inverse of any signal. AND gate means it is just multiplicating the signal. OR means it is adding x plus y in case of OR. Okay, 1 minute. Okay. Any confusion? Any confusion? What is NOT gate? What is AND gate? And what is OR gate? अभी कंफ्यूजन थोड़ा थोड़ा रहेगा, कोई इशू नहीं, बाद में जब हम लोग करेंगे इसके ऊपर न्यूमेरिकल्स वो सारा कुछ क्लियर हो जाएगा. But you please remember the fundamental, only three fundamental gates are there. That is your NOT gate, which can generate inverse of any signal. Inverse means आपने अगर 0 प्रोवाइड किया है तो आपको आउटपुट में 1 मिलने वाला है. अगर आपने 1 प्रोवाइड किया है तो आउटपुट में 0 मिलेंगे आपको. And AND gate means it is just multiplication. Whatever signals you have fed it or inputted in your gate, you will get the multiplication of all those signals. Then OR gate means it is just addition. X and Y अगर आपने इनपुट दिया है तो X plus Y आपको आउटपुट में मिलने वाला है. That's it. And NAND gate, NOR gate and XOR gate, all these three gates, यहाँ इसके ऊपर और एक और इसके ऊपर भी और 2-3 गेट्स है. सारे गेट्स हम लोग ये 3 फंडामेंटल गेट्स जो भी है नॉट एंड और से हम लोग डिराइव कर सकते हैं. सो बेसिकली 3 फंडामेंटल गेट्स आर देयर. दैट्स इट. नेक्स्ट one by one we will see now what is AND gate. The symbol of AND gate is, this is 2 input AND gate. 2 input AND gate. क्यों 2 input है? Because A and B, these are your input, C is the output. So 2 input AND gate. This is the symbol of AND gate. AND gate का symbol ये है, आपको ऑलरेडी फर्स्ट स्लाइड में दिख गया था. And this is called truth table. Truth table means 2 input, अगर 2 input है तो वहां पे कितना पॉसिबल कॉम्बिनेशंस हो सकता है आपका. Can anyone tell me? If you have 2 inputs, then how many possible combinations can be generated? 4, because 2 to the power 2 equal to 4. So I can write 0 in the input, I can write 0 1 in the input, I can write 1 0 in the input, and 1 1 can be written. And this is the expression. I have already told you people, this is just multiplication. A into B. यहाँ पे डॉट से इसको रिप्रेजेंट किया गया है, A dot B. Then what will be the output? 0 into 0, 0, 0 into 1, 0, 1 0, 0, 1 1, 1. आपको ट्रू वैल्यू कब मिल रहा है? When your output is having 1, when all both the input is equal to 1. In AND gate, you are getting one output. That means your output is generating 1 if and only if both the input is equal to 1. Please remember. Okay. If both the input is equal to 1, then only you are getting output 1 at your AND gate. Any confusion? Very simple. Yes. Next gate is your OR gate. OR gate. The symbol of OR gate is this. देखो सिंबल में क्या डिफरेंसेस है, यहाँ पे क्या है और यहाँ पे क्या है. OR गेट थोड़ा अलग है. तो दिस इज द सिंबल ऑफ OR गेट. नेक्स्ट टाइम से अगर ये गेट आपको मिल जाए, दिस मीन्स OR गेट, और अगर इस तरह का सिंबल मिले तो इसका मतलब ये है कि आपको AND गेट है, आपको AND गेट मिला है. तो OR गेट हम लोग देख लेते हैं. व्हाट इज द डिफरेंस, व्हाट इज द कैरेक्टरिस्टिक्स ऑफ OR gate. This is also a 2 input OR gate. Generally we use 2 input OR gate. ठीक है, मतलब कोई भी सर्किट अगर हम लोग फंडामेंटली यूज करते हैं तो 2 इनपुट का ही लिया जाता है. इसीलिए यहाँ पे आपको मैक्सिमम एग्जांपल्स 2 इनपुट के ही मिलने वाला है, और आपके लिए उतना सफिशिएंट है. 3 इनपुट 4 इनपुट ये बाद में आएंगे, वो हायर स्टडी में आप लोग पढ़ोगे. यहाँ पे आपको सबके सब 2 इनपुट्स गेट ही मिलने वाले हैं, या तो AND गेट हो, या तो OR गेट हो, या तो NOT गेट हो, कोई भी. NOT गेट में एक ही इनपुट रहता है, 2 इनपुट कभी नहीं होता है. सॉरी, NOT gate is having always 1 input 1 output. Then this is the truth table of your OR gate. You can see here also we can generate 4 combinations of input. 0 0, then we are getting 0, 0 1 we are getting 1, 1 0 we are getting 1, 1 1 we are getting 1. So this is the expression how to calculate the OR gate. C is equal to A plus B. I already told you people this is your addition. So 0 0 0 0 1 1 1 0 1 1 1 1. So here you can see in three possible in three places we have 1. That means if any input of OR gate is equal to 1, then you are getting output 1. अगर कोई भी एक इनपुट में आपका 1 है, if I fixed any one of the input of OR gate equal to 1, then it is automatically 1 at the output. आउटपुट में आपको 1 ही मिलेंगे, आप इसको 0 करो और 1 करो कोई फर्क नहीं पड़ता। क्या बोल रहा हूँ समझ में आ रहा है? If I fixed any input of this 2 input OR gate, let's say I have fixed at 1, a equal to 1 always, a equal to 1 always, अगर ये मैंने फिक्स कर दिया तो आउटपुट में हमेशा आपको 1 मिलेगा। Is this clear? Is this clear what I am trying to say here? If I placed 1 at any input of OR gate, then you will automatically get 1 at the output. What it does not matter b is 0 or 1. अगर 0 भी होगा तो भी आपको आउटपुट में 1 ही मिलेंगे b, और अगर 1 हुआ तो भी आपको 1 मिलने वाला है। Similarly, in case of AND gate, if I fixed 0 here, you will get 0 at the output. Is it? If I fixed 0 at any input of your AND gate, then automatically all the output will be 0. Yes? Any confusion? Any confusion? ओके वेरी गुड। अगर एंड गेट में हम लोग 0 प्लेस करेंगे कोई भी एक इनपुट पे तो आपको आउटपुट में 0 ही मिलेंगे, आपको आउटपुट में 0 ही मिलने वाले हैं। अगर आप यहाँ पे सारा 0 कर दोगे तो आप बीज में कोई भी वैल्यू रखो, 1 रखो 0 रखो, आपको सारा का सारा 0 मिलने वाला है। लेकिन और गेट में क्या है, अगर आप 1 करोगे कोई भी एक इनपुट, देन यू विल गेट 1 एट द आउटपुट। ठीक है, अगर मैं इसको 0 करता हूं तो कोई फर्क नहीं पड़ता, आप यहाँ तब ये दूसरे इनपुट में 1 देंगे तो यहाँ पे 1 होगा, 0 देंगे तो 0 होगा। इट मीन्स एट एंड गेट इज ऑलवेज एसोसिएटेड विद 0। अगर आप एंड गेट में 0 करोगे तो आप आउटपुट इज ऑलवेज 0। एंड सिमिलरली एट OR gate, if you placed 1, output is always 1. So please remember, AND gate is always associated with 0, OR gate is always associated with 1. डिफरेंस समझ में आ रहा है? क्यों 1 है यहाँ पे, वहां पे क्यों 0 है? Any confusion? Any confusion?
No, sir.
Oh, okay, very good. Next, this is your NOT gate. This is also sometimes called inverter gate. Inverter gate or NOT gate, and it is known to you. This circuit shows you that one input is there and one output is there. There is one bubble. It is called bubble. Bubble means it is represented as a NOT gate actually. Bubble or NOT gate दोनों same होता है, और this is the circuit symbol of your NOT gate. Whenever you see this type of representation, it means it is a NOT gate. And I already told you people, if input is 0, you will getting 1. If input is 1, you are getting 0. So this is the expression B equal to A inverse. यहाँ पे inverse मतलब आपका NOT gate, inverse or NOT gate. ठीक है? Next, a logic buffer gate. A logic buffer gate means this is just buffer gate. Buffer gate means you can store your input. ठीक है? This is not the fundamental gate. Only 3 fundamental gates are there. That is your AND gate, OR gate, and NOT gate. Now they are talking about logic buffer gate. What is logic buffer gate? That means a gate which can store whatever input is there, you can store at the output. Okay, this is योर लॉजिक बफर गेट। दैट मीन्स इनपुट में 0 है तो आउटपुट में भी आपको 0 मिलेंगे, और इनपुट में 1 है तो आउटपुट में भी 1 है। दिस इज एक्चुअली नॉट रिक्वायर्ड फॉर योर that means in this subject this is not required, because it is simply we can say that this is a where or you can say bus, क्योंकि ये जो आपका इनपुट में है वही आउटपुट में है, इसमें कोई कंप्यूटेशन नहीं हो रहा है। बट दिस टाइप ऑफ गेट also sometimes required, okay, this buffer gate also sometimes required to store input, and this is basically required at the at pipelining जब हम लोग पढ़ेंगे after mid semester, when we study pipelining, then we need this type of gate to store the result of intermediate result of any gate. So base for pipelining में होगा. So now please remember this type of gate or this type of buffer gate can store whatever input you have in your input, then it is directly store that input at the output. Okay, and this is actually not a very frequently used gate. This gate is only used in case of pipelining where we need to store some intermediate result. So just आप याद रखो, but ज़्यादा इसका importance कुछ है नहीं. Next is your AND gate. NAND gate, sorry. NAND means ये जो term है आप यहाँ पे देख सकते हो. First AND represents a NOT gate and second is represent a AND gate. So this is your AND gate and last में एक bubble है. This represents a NOT gate. This is your AND gate and A and D and this is your NOT gate. Bubble represents your NOT. So यहाँ पे नाम पे भी आप देख सकते हो AND, उसके पहले है NOT and NAND, NAND gate. So NAND gate is a combination of AND gate and NOT gate. ठीक है? This means आपका जो ट्रूथ टेबल बनेगा वो कैसे बनेगा? How you need to form truth table? ट्रूथ टेबल में क्या होगा? AND गेट का जो ट्रूथ टेबल है, जो आउटपुट है, उसको बस रिवर्स कर दो, because in case of AND gate we are having 0 0 0 0 1 0 1 0 0 then 1 1 0, but we are supplying an inverter or NOT gate at the end of the AND gate. ठीक है, तो आपका जो आउटपुट होगा वो रिवर्स कर देने से हो गया बस. सो यहाँ पे भी आप देख सकते हो सिंपली कि A dot B, this is your AND gate and just inverse the output of AND gate. So 0 0 क्या हो गया यहाँ पे आपका 0 0 in case of AND gate. If I supply AND to this AND gate, 0 0 यहाँ पे है तो AND gate क्या जनरेट करेंगे 0, और नॉट में अगर उसको सप्लाई करेंगे तो यू विल गेट 1. सो आउटपुट इज 1. 0 1 0 1 मतलब यहाँ पे अगर 0 1 प्रोवाइड करूंगा एंड गेट पे, देन आई एम गेटिंग 0, बट आफ्टर दिस आई हैव ए 1 इन्वर्टर और नॉट गेट, सो आई एम गेटिंग 1. Similarly in case of this, but in case of 1 1 you will get 0, because 1 1 in AND gate I am producing 1, but because of this inverter gate or NOT gate I am producing 0. So this is your 0. Similarly you can place here also, no problem. 0 0 you can place 0 into 0 क्या है 0, then inverse equal to 1. So this is your combination of AND gate and NOT gate, and this is called NAND gate. Please remember, NAND gate is a combination of AND NOT. Any confusion? Very good. Next is your NOR gate. So similarly in case of NOR gate, it is a combination of your NOT gate and OR gate. NOT and OR. So यहाँ पे आप देख सकते हो, this is your Boolean expression. Boolean expression for NOR gate. A plus B bar. A plus B bar. So whatever output you have in your और गेट में जो भी आउटपुट था आपका उसको बस रिवर्स कर दो, सो यू विल गेट द आउटपुट ऑफ नॉर गेट. दिस इज द नॉट गेट. Bubble represents here not gate, and this is your or gate. So this is called NOR. NOR means not plus or. Okay, so simply the reverse of your OR gate. OR gate में क्या होता है, पहले वो कंप्यूट करो फिर उसका आउटपुट लिख दो नॉट करके. OR gate में 0 0 क्या है, अगर ऐड करेंगे 0 plus 0 you will get 0, but we have a NOT gate at the end, so output will be 1, because we know NOT gate always inverse the output. 0 plus 1 1, but NOT gate के कारण क्या होगा 0. 0 plus 0 1 plus 0 1, NOT gate है 0. 1 plus 1 we will get 1, but because of this NOT gate the output is again 0. So this is your NOR gate. Any confusion here? Good. Then this is your exclusive OR gate. This is the gate which is used more frequently in your digital electronics circuit. डिजिटल इलेक्ट्रॉनिक्स में जितने भी सर्किट्स है एक्सक्लूसिव और सबसे ज्यादा यूज होता है, बिकॉज ऑफ इट्स प्रॉपर्टी. इट हैज many property and some good properties, and this is the symbol of exclusive OR gate. exclusive OR, ये तो हो गया आपका OR गेट, और यहाँ पे सामने में और एक मैंने यहाँ पे लगा दिया है कुछ इस तरह से, तो दिस इज कॉल्ड एक्सक्लूसिव OR गेट. Exclusive OR is the function of exclusive OR is this is the symbol. यहाँ पे अगर आपको प्लस उसके बाद सर्कल मिल जाए तो this is your exclusive OR. And if I simplify this equation, it will get a b bar. यहाँ पे लिखता हूँ मैं फिर से, आपको दिखा नहीं देगा. ये अगर मैं सिंप्लीफाई करूँ तो you will get a b bar plus a bar b. This is the expression for exclusive OR. Please remember this expression. If I simplify this equation, you will get a b bar plus a bar b. A b bar means this is your AND gate. A b यहाँ पे दोनों एक साथ है, a dot b. This is AND gate, and b का क्या है, इनवर्स है, प्लस, तो ये OR gate है. फिर a reciprocal, or you can say inverse, a inverse b. So if this type of expression you are getting somewhere, you can directly write, I can realize that expression using your exclusive OR gate. Exclusive OR gate. And this is the truth table of exclusive OR gate. You can see here, if both the input are same, if both the inputs are same, like 0 0 and 1 1, you will get 0 at the output. If both the inputs are not similar, then only you will get 1 at the output. यहाँ पे 0 है, 1 है input में, तो you will get 1 1 0, then you will get 1. So if both the input is equal to 0 or 1, ठीक है, then you will get 0 at the output. And if both the inputs are not similar, that means one is 0, either is another is 1, or you can say first one is 1 and second one is 0, then only you can generate 1 or true value at the output. Any confusion in the exclusive OR gate? Please remember this expression, it is very important. This expression, please remember, a b bar plus a bar b. If I simplify this equation, ठीक है, then you will get a b bar plus a bar b. This is very important, please remember. Then exclusive NOR. Exclusive OR, then exclusive NOR. Previously we have discussed, this is your exclusive OR. Exclusive OR को अगर हम लोग बार लगा देंगे यहाँ पे ऊपर में एक, then you will get exclusive NOR. exclusive NOR, the symbol of this gate is same, only difference is you have a bubble in the at the end, and that is why the output is just the reverse of exclusive OR gate, reverse of your exclusive OR. In case of exclusive OR, we have 1 at the output if both the inputs are not same. एक 0 होना चाहिए, एक 1 होना चाहिए, then only we are having 1 at the output. but ये तो inverse हो गया आपका, तो यहाँ पे आपका वो दोनों 0 है. और if you have same input at the input, that means if the inputs are equal, okay, then you can generate 1 at the output in case of exclusive NOR. and the expression, इसका expression क्या होगा, a b प्लस a b, यहाँ पे दोनों में बार. The simplified equation for this exclusive NOR is ab plus a bar b bar, ab plus a bar b bar. Any confusion? Then they are saying here Boolean constants. Boolean constants means these are 0 means false, 1 means true. Please remember, now onwards, if I say true, true means always 1, false means always 0. False means always 0, true means always 1. Then Boolean variables, it is known to you. Boolean variables is nothing but your 0 and 1. Then Boolean functions is nothing but your logic functions, or you can say logic gates. Logic gate क्या क्या है आपका? And or not. I already told you people, these are the 3 fundamental gates through which we can generate everything, every gate in the digital electronics. So these 3 gates are called complete and sound because these 3 gates are capable to generate every gate in the digital electronics. That is your NAND gate, NOR gate, exclusive or exclusive NOR, everything we can generate using AND or NOT. Please remember, Boolean functions, any Boolean functions we can generate using these three gates. Then Boolean theorems, we will see Boolean theorems. There are lot of theorems. Associative law है, distributive law है, De Morgan's law है. So यहाँ पे भी लिखा गया है see text for details. यहाँ पे आपको मैं नेक्स्ट क्लास में बताऊंगा these theorems कैसे कैसे हम लोग देखेंगे, ठीक है. So Boolean laws, these are the laws. This is your De Morgan's theorem. This is your distributive, associative, commutative, everything we need to discuss. Okay. So यहाँ पे आप focus करो पहले how these gates are behaving actually. तो ये already मैंने आपको एक बार वहाँ पे बता दिया है, फिर भी जिसको समझ में नहीं आ रहा था वहाँ पे, if I generate one circuit using OR gate. OR gate means this is actually parallel connection. This is OR gate means parallel connection because in this case we have addition A plus B, A plus B. So if any gate is closed, okay, if any gate is closed, close means अगर मैं वहाँ पे इसको 1 कर दूं, ये यहाँ पे मैं इसको लगा दिया हूँ, then you will get the output. ठीक है. सो यहाँ पे वही दिखाया गया है कि अगर आपका एक भी गेट अगर क्लोज्ड है मतलब क्या है, 1 है, तो आप करंट जनरेट कर सकते हो. ये इतना इम्पोर्टेंट है नहीं, बस आप समझने के लिए आपको दिया गया है कि OR गेट जो है वो पैरेलल कनेक्शन में चलता है. OR gate is always in parallel connection. It means if any gate is closed, current can pass from this line. If both the gates are closed, then no problem, currents are passing from both the gates. But if any one of the gate A or B is closed, then you are getting output at the C. But in case of AND gate, this is a serial connection. In case of serial connection, you need to close both the gates. Then only you will get output at the and C, which is not true in case of OR gate. OR gate में एक भी अगर close रहा तो आपको output मिल रहा है, but in case of AND gate you need to close both the gates, A or B. A and B, sorry, A and B, both the gates you need to close. In case of AND gate, then only you will have output at your output C. But in case of OR gate, which is not true. So this is the difference between AND gate and OR gate. Okay. Then yes, these properties we will discuss in the next class. Commutation, then associative property, distributive property, then binary addition we will see in the next class. Any confusion till now? Okay, so please revise whatever I have discussed till now. Okay, and then if you have any doubt, then you can ask me in the next class. We will discuss the laws of your Boolean laws. Okay, Boolean laws, and then we will see some theorems of your digital electronics, how to write those functions. So we will meet in the next class. Thank you very much.